Hi, 8th grade. This is lesson 2 of module 12, Understand Scientific Notation. And the I can statement says, I can use scientific notation to describe very large or very small quantities and to compare quantities. So they have vocabulary here. It's basically the same thing. Scientific notation is a method of writing very large or very small numbers using powers of 10. In scientific notation, a number is written as the product of two factors. The first factor is greater than or equal to 1, but less than 10. And the second factor is a power of 10. And you'll see that, I think you've done this a little bit before, but you'll see that how that works as we go along. So what does $1 trillion look like? If you could stack 1 trillion $1 bills, the stack would be about 68,000 miles tall. That is more than 1/4 of the distance from the Earth to the moon. That's pretty tall. So the standard or decimal form of a number is one way to write numbers, and that would be this way. That's just the standard form. It uses the base 10 system to show all the numbers' digits. For example, the way to write 1 trillion in standard form is like this, with all those zeros. There is a shorthand way called scientific notation to write large numbers without so many zeros. So 1 trillion in scientific notation looks like this. It's the number 1 times 10 to the 12th. So what I'd like you to do now is try to do A, B, and C on your own, and then we'll come back and work on those together. So A says, to write 68,000 miles in scientific notation, first move the decimal point to the left to get a number that is greater than or equal to 1, but less than 10. So you can see they moved 1, 2, 3, 4, so the decimal point moves 4 places to the left. And then you remove these extra zeros, and you get the first factor is 6.8 because it moved right to here. Use this factor and a power of 10 to write the number in scientific notation. So 68,000 equals 6.8. That's our first factor. And because we had to move that decimal point 4 places to get there to 6.8, it's 6.8 times 10 to the 4th. When you write a number in scientific notation, its value does not change. So these are equal. 6.8 times 10 to the 4th is the same as 68,000. C, write 1 billion in scientific notation. So you can just count until you get to this point here. And you had to move the decimal point 9 places, so you have 1 times 10 to the 9th. So let's look at the next page. So number 2 says you can also use scientific notation for very small numbers. The thickness of a dollar bill is about 43 10,000 inches. Write this quantity in scientific notation. So try to do number 2 on your own, A and B. And then it says in number 3, in 2016, the United States Mint produced about 9.1 times 10 to the 9th pennies. Write this quantity in standard form. So now they're having you go the opposite direction. So try to do those two, and we'll come back and look at them together. So A tells you first move the decimal point to the right to get a number that is greater than or equal to 1, but less than 10. So this time you're moving the decimal point this way, 1, 2, 3 places. So it moves 3 places to the right. So you're always moving the decimal point whichever way you need to get that number between 1 and 10, or greater than or equal to 1, but less than 10. And so you're going to take all those zeros off, and you have 4.3. Since 4.3 or 43 10,000ths is less than 1, you move the decimal point to the right. So the exponent in the power of 10 will be negative. So it equals 4.3 times 10 to the negative 3 power. Number 3, in 2016, we read that. A, use the power of 10 to determine how many places you will need to move the decimal point. So this power of 10 tells me that's how many places I need to move that decimal point. So if I have 9.1, and then I want to move that 9 places, 1, 2, 3, 4, 5, 6, 7, 8, 9, I would just fill in zeros there. And so then I can kind of put in commas. So you move that decimal point 9 places. So 9.1 times 10 to the 9th is 9 billion. 100 million pennies. So now let's look at question number 4. So this says scientific notation makes it easy to compare quantities. So pause here, try to do A on your own, and then we'll come back and look at it together. So A says a table shows the number of half-dollar coins produced in 2016. So here's the production for the Denver Mint, all U.S. mints. Use a ratio to compare these quantities. So here's the ratio that they give you. And they're both, the powers of 10 are the same. This is both 10 to the 6th. So you have 10 to the 6th over 10 to the 6th. That's the same as 10 to the 0 because you know that you'd subtract 6 minus 6. And you also know that 10 to the 0 power equals 1. So compare the first factors. So this first factor here is 4.2. And then they have that second one filled in, 2.1. So what is 4.2 divided by 2.1 equals 2. The total number of half-dollar coins is about 2, which is this number here, times 1, which is the number that we got when we were looking at our powers of 10. So it equals about 2 times the half-dollar coins minted in Denver. So you can try the turn and talk on your own, and then we will see you in the next lesson.